All right, for this question, the easiest thing to do is just know the formula that works for exponentials, the kind of like y equals mx plus b version for exponential equations. And I'll show you that at the end. But I think if you had trouble with this, it's probably because you don't know that formula, and so you feel like there's nothing you can do. But that is a bad feeling. You are wrong. There is something you can do because the story itself gives you the instructions for how to figure out which equation works, right? So they're telling us this story and about how these pollen grains are increasing. We should just follow the story and do what we're told and arithmetize here, right? Remember, arithmetize is our way of taking abstract algebra, like the 4 equations that were given, and understanding it more concretely using real numbers. So we can just calculate the pollen, right? So they're telling us it starts with 310 pollen grains during the first year, and then there's a 1% annual increase. Okay, so if we said that t is 1, we can figure out what would happen just based on the story. So we'd have 310 pollen grains, and then we want to find 1% of that. So you know how to find a percentage, hopefully. So we would just multiply 310 times 0.01, which is 1% as a decimal, right? So we take the amount we're starting with, and we're adding on 1% of 310. So you might be able to do that in your head, but let's just do it in the calculator anyway. 310 times 0.01 is 3.1. So we're adding that on. And that's going to get us 313.1 pollen grains after 1 year. Now, the equations are supposed to represent that exact same situation, so we can plug these numbers in and see which equation gives us the same result, right? So if we looked at choice A, that wouldn't make any sense because this would be 310 to the first. Well, 310 to the first is just 310, right? But it's supposed to give us 313.1. That's the magic number. So that's no good. You know, that doesn't work. Now we gotta use the calculator for these other ones. Let's see, I should kind of squeeze this in here. So for choice B, that's 310 times 1.01 times 1, which is just 1.01. So 310 to the 1.01 is a crazy number, 328.3, 328 point something, whatever, but it's not the 313.1 that it's supposed to be. Let's keep going. Choice C is 310 times 0.99 to the first, which is just 0.99. So again, we might be able to do this in our heads, but the calculator tells us that it's 306.9, less than what we started with, so that's no good. And then hopefully this gives us what we want. 310 times 1.01 to the first, so 310 times 1.01 is indeed 313.1, the same number that we were supposed to get based on our own math for this, right? So we did the math just based on what math we're comfortable with, knowing how to take a percentage of something. The SAT's equations here are a little bit more complex, but no matter what, we should get the same answer, and that's why arithmetize works. It lets us visualize something that might be a little confusing if we had to squeeze an entire story into one equation. But by taking it piece by piece and doing the steps independently, we can still figure out what's happening, and then use the equation to kind of check our work and see whether we get the same answer. So this is a perfectly valid way to get this answer. There's nothing wrong with this. And quite frankly, you need to do this if you were having trouble with this question. You should not be skipping this. This took very little time, and with a calculator, it's even easier. So this is a must-get question, and arithmetize makes it possible. Now, to get it faster, we really just need to know how these equations are formed. And so the way that I teach my students is that I want them to use the open formula. Basically, anytime we're dealing with percentages, this open formula is supposed to help us keep track of all the pieces, because on the SAT, it's easy to lose track of what's going on. So for basic percentages, the open formula is the original value, the number we're starting with, times the percentage as a decimal. E stands for equals, and n stands for the new value. The difference, though, is when we have exponentials, we're really talking about a percent change, and we have this variable of time. So we've got to account for both of those things. So what I do instead is I use a slightly different version of this formula that goes O, which still stands for the original, times 1 plus or minus P equals N, and that's for a percent increase or decrease. But because it's over time, we can put the t as the exponent to account for the fact that it's increasing multiple times for multiple years or months or whatever. So this formula in orange is the one we're going to use. The n is the p of t, right? That's the new amount after however many years the pollen grains are being deposited. The o is 310 because that's the number that we started with, 310 pollen grains. And then this piece is a little weirder. 1 represents the 100%, meaning the fact that we have 100% of the grains we started with. So that part's a little confusing, but you'll see that when we do a increase, right, because it's an increase, so a plus of 1%, 0.01, if I simplify this, 1.01 to the t is exactly what my p of t is equal to, right? So it's the same equation. Because what's happening is we're not just doing 1%, we're doing 101%, right? Every year we have 100% of the previous year's pollen plus an extra 1%. So that's why that 1 is built into the formula, is it accounts for the fact that we have kind of like a starting value and we're changing from that value. If we had a decrease, then it would look more like choice C, where we took away 1% from the 1. So it's even more important when we have decreases to think about this formula, because the percentage that we're given won't actually appear in the formula, making it even more confusing. So a lot of stuff I just threw at you for a number 26, a harder question. And so that shows we've got two paths to the answer for a question that's going to stump a whole lot of people. My preference is that you learn the formula so that you can very quickly recognize where all the pieces go. But if you don't memorize it, that's no excuse for getting this wrong. You can absolutely arithmetize on most exponential questions and use your calculator to kind of see what that change is going to be, and then just try to match your equation based on whatever work you did. So you've got some options. Take advantage of the SAT strategies to get a lot of these hard ones right, even if they confuse you at first.